We have several methods in computing for the volume of a solid figure in calculus. The first method that we did was the disks method, which is basically a solid figure generated by a function rotated along the x-axis. Now imagine taking out a slice of your solid figure. It will create a disk-like figure, and this method is what we're going to use if we have a function being rotated on the axis and giving us a solid figure like a cylindrical cone. Now the formula in finding the volume of this particular solid figure is pi times the integral of radius squared from a through b dx. So this is what we did on our previous lesson, and today we're going to be focusing on the other method of computing for the volume of a solid figure, which is the washer's method. Now graphically, it's going to create a washer's method, or this method can be used when you rotate the same figure. So imagine this is the same figure, but instead of rotating it along the x-axis, we rotated it on the axis or on the line y is equal to -1, given by this line right here. So if we rotate this figure, it will create a hollow solid figure at the middle. So this particular center right here, which is hollow, is included in our formula. So we are generating two radii by doing this particular method. Therefore, we're going to use this formula in finding the volume of a solid figure, which creates a washer as a slice of figure that you can take out from the solid figure. And the formula for the washer's method will be pi times the radius outside the solid figure, or the outer radius squared, minus the inner radius squared dx from a through b. And this is what we will use today in computing for the volume of some figures that will generate a hole in the middle. So for our first example, we're going to compute for the volume of this solid using the region enclosed by the curves y is equal to x and y is equal to x squared being rotated about the x-axis. Now the first thing that we need to do is to visualize the graph of our two functions. So we have y is equal to x squared, which is a parabola, and y is equal to x, which is a line. So this is our figure giving us a line and a parabola going up. And the area that we are considering will be in between the function y is equal to x and y is equal to x squared. Now, according to the problem, we're supposed to rotate or revolve this particular figure or function along the x-axis. So imagine rotating your solid figure on the x-axis. It will generate a solid figure which has a hole in the middle. So in this particular solid figure, we're going to use the washer's method because we have two radii or two circles that will be formed in our solid figure. So we are going to find what the outer radius is and what the inner radius is by just looking at the graph. So if we rotate this figure, this will be your inner radius and the longer radius will be your outer radius. Now to find the measurement of our outer radius, it's basically top minus bottom, which gives us the top function, which is x, and the bottom function, which is 0. So x minus 0 will give us x. And for our inner radius, it's still going to be top minus bottom, but in this particular case, the top function will be our parabola, which is x squared minus 0, giving us the inner radius at x squared. So now that we have our two radii, the first radius, which is our outer radius, which is x, and the inner radius, which is x squared. Now plugging it into the formula for finding the volume of a washer, we'll have pi times x squared minus x squared raised to 2 dx from 0 to 1. So the interval is from 0 to 1 because the point of intersection of function y is equal to x and function y is equal to x squared will give us x value of 1 and y value of 1. Now, plugging into the formula and simplifying your integral function, it will give you pi times x cubed all over 3 minus x to the 5th all over 5 evaluated from 0 to 1, which gives us 2 over 15 multiplied by pi, which is in the formula. Therefore, the volume of this function being rotated on the x-axis will be 0.419 unit cubed. And this is the method or the washer method that we're going to use in finding the volume of a solid figure. X squared and y is equal to x being rotated along the x-axis. So this is our parabola and this is our linear equation. Now imagine having this function and rotating it along the x-axis. It will generate a washer in our function, and that is what we're going to use in finding the volume of our solid figure. Now we just need to find the outer radius, which gives us x, and the inner radius, which gives us x squared. Now substituting it to the formula, and we'll have the volume equal to pi times x squared minus x squared raised to 2, which is your inner radius from 0 to 1. And if you evaluate your integral function, it will pretty much give you a volume equal to pi times 2 over 15 or 0.419 unit cubed. And that is how we use the washer's method in finding the volume of a solid figure. Now let's have another example. Now in this example, we are still using the same function, which is y is equal to x and y is equal to x squared. The only difference is we're going to rotate it about the line x is equal to -1. And x is equal to -1 is a vertical line right here, parallel to your y-axis. So if we rotate our figure along the y-axis or along x is equal to -1, it will create a solid figure with a hole. Therefore, it's going to give us the washer method in finding the volume of our solid figure, given by this formula. So the first step is, since we are rotating it along the y-axis or along the line parallel to the y-axis, we're going to change our function from a function with respect to x. Now we're going to convert it to a function with respect to y. So y is equal to x squared will be x is equal to the square root of y, and y equal to x is going to be x is equal to y. So this is our new function which we will use, because to find the outer radius and the inner radius, we're going to use the right to left method. So it's no longer top minus bottom. Now we're doing right minus left. So for the outer radius, the right function will be the parabola, which is square root of y minus -1, which gives us square root of y plus 1. So this is the measurement of your outer radius. And the measurement of your inner radius will be the line y is equal to x converted to y. So now it's y minus -1, which gives us y plus 1 as the measurement of the radius of your inner radius. Now to plug it into outer radius and inner radius squared, we'll have the volume equal to pi times the integral of square root of y plus 1 squared minus y plus 1 squared dy integrated from 0 to 1. And if we evaluate this function from 0 to 1, it will give us 1/2, which gives us pi over 2 or 1.571 unit cubed. And this is how we compute for the volume of a solid figure along or rotated along the y-axis or a function parallel to the y-axis.